Hello friends, today we will see face milling without wall. So we have this component, and for this component first of all I am going to change machine coordinate system. Here you can see the direction of Z in opposite direction. So double click over this NCS mill, and here you can adjust your Z direction according to your part. So right now the tool direction is okay and the tool will come from Z direction, and click OK. Here in workpiece, double click over this workpiece, and my part is this one. Select this part, and blank is this bounding block, and I'm going to use facing operations. So I'm adding some value 1.3 on top. So I'm going to cut this 1.3 mm on this top, and for this operation, now after selecting this workpiece, I need a tool. So here I'm using a 20 mm face mill. Okay, enter 20. If you will see, the tool is in opposite direction just because of our default coordinate system, because that coordinate system is in downward direction. If you will change it, it doesn't affect. If it is not in proper direction, it doesn't affect. When we will select any operation, that time it will work according to the tool direction which we have specified in tool axis, right? So here we can just entering the values and hit OK. Now select this create operation, and the operation is face floor facing without wall. Here we will face the upper surface of any model, and model may be a regular or irregular in shape. It doesn't affect. It will work on the planar surface. In floor face without wall, we work on the planar surface, or we can select the outer boundaries or curve, uh, so that we can cut that inner portion, right? So let's see. Now select the folder. The folder is this program file, and here the tool is this Facemel, and workpiece is this, and I'm using finishing operation. Now come to this and select the surface to be cut, and here I am not using any stock. This is my finish operation, and my cut pattern is zigzag. If you want to change, you can change, no problem, but here I am using zigzag. Stock is still 0. The blank is 3D IPW because this is the very first operation, so you can use blank geometry instead of 3D IPW, right? If you want to use 3D IPW, it doesn't affect, but it is advisable if you are using the first operation, use blank geometry. And the depth of cut, I'm using 1.0, and now generate the tool path. Let's see. Okay, in 3D dynamic, it is okay. Now come to this geometry, and here geometry we have already defined. If you want to skip any areas, any boundaries, so we can use this trim boundary. So here I'm just showing you how to define this trim boundary. We can use this with the help of curve or face. So if you are using a face, select the face, and here the plane, you need a plane on the top, right? So you can see this is a top curve and the face. Now generate. The tool path is generated only for the outside of this trim boundary. Okay, okay. Now again come to this trim boundary and remove this boundary. Here instead of face I can use this curve also. Here, use this tangential curve. Okay, and trimming side is inside portion will trim. Plane, keep this automatically it will let the top face. Okay, and now the same result we will get, same result. So we can skip any area with the help of trim area. Okay, now remove this because I don't want this. I am just showing you what is the use of this trim boundary. Tool axis, here you can see when we are generating a tool path, the tool is in right direction. Why it's so? At the initial, we have seen the tool direction, the Z direction is downward, and we have changed. Still, still here, it is not following the Z direction. Here, it is using normal to first face. This is the first face, and the normal to this will be this up direction, right? That's why it is working properly. If you want to change, you can change this Z direction. It is also the same option. It will work same as it is working with normal to first surface, but it will be different when we are using 4 axis operation or 5 axis operation. That time both are different. Okay, that time it will not work. Both will work differently. So leave this, come to this strategy, and here if you want to define the cut angle, see right now we have this type of toolpath. If you want to use cut angle, so you can specify, click here and enter the angle. Here it is 45, so toolpath will generate at an angle of 45 degree, right? We have one separate option for this zigzag, floor facing zigzag, right? So here we have one more option, longer edge. So the toolpath will generate for the longer side. Generate it again. This is the longer side. And vector. So you can also define any vector, right? This is direction, what I want, right? So toolpath will generate in that direction. Okay, and specify two-way vector. Here I don't have any taper vector. Here yes, wait, I have this vector. So click here, or if you want to change, you can use this for defining the vector first point and second point. This is the vector. Now generate and see. Okay. So in this way, we can create this face floor facing without wall operation. Hope you understand this properly. Okay, and this one is a little bit similar to this one, right? So we have already discussed these two. So hope you understand this. Thank you for watching. Have a nice day. Hello friends, today we will see floor and wall operation under this planar milling. This is the fourth option, and we use this option to remove the material from the planar surface. And if we have multiple pockets, so we can use multiple times this operation, and this operation is especially for flat surfaces. So first of all, I am going to define a new geometry because I have already done some operation in this previous workpiece. So click here to add a new geometry, and here this is the geometry. Select this workpiece and select this location. The location for this geometry will be MCS. This MCS is my machine coordinate system, and I want to use the same for this geometry also. So enter a name. Now okay, and here first specify the part and select this solid part. Now we need the blank So select the blank and we have bounding block we have already used. It creates a box around the part, but this time I am going to use part outline. See this. For blank geometry, we have several options. The bounding block we have already seen. This bounding block creates a block or a box outside the part, and in this part outline, outer surface or outer curve of a part will be extruded at a certain height. If you want, you can increase this outer limit using the offset, and it creates a block. So in floor and wall, we use this operation for prismatic part, and here we have three type of option to remove this material. First is blank geometry. We can create the tool path for the blank geometry. The blank geometry is outline. Outline part is our blank geometry. So initial blank which we are going to use, we can cut that blank uh, for the very first operation. And after any operation, the remaining material which is available on the part, we will use that material as a in process workpiece. The material which is left after the operation, that is called IPW, and it is very important. We will use this term again and again. And thickness, if you know, we have only 2 mm material on this floor, so we can also specify the thickness of the material on the planar face so that we can cut it. So we will see all three operations. So first we will use this blank geometry and IPW. So this time I am using part outline. So outline is this type of curve, and here if you want, you can increase the offset. Outline will offset and it creates a solid body, but in this case I don't want this offset, so click OK and OK. Now I need a tool, so click over this create tool, and for this operation I'm going to retrieve a tool from the library. So click here, and my tool will be a non-indexable tool, so click here, again OK, and see this. This is 8 mm, again 8 mm, and one more 8 mm tool. So this is the library. Here you will find all type of tool, mostly which we can use. Okay, so these are animal, and this is the tip radius tool. So I'm going to use this UGT 201002 and click OK. Now don't click OK, just cancel it, and you will find this tool in this tool view. This is the tool. Now click here to create the operation. So the operation is floor and wall, and I want to place this operation under this program folder, and this is my working tool, and this is the geometry, and I'm going to use this operation as a roughing operation. Here first specify cut area floor. So select this area, this floor which we want to cut, select it. Okay, and specify wall. So I'm just selecting this automatic wall, and it will automatically detect the wall. See, this dark blue will represent as a wall. Now generate and see the result. Let's verify and see the tool is cutting this complete depth in a single pass. So we need to define this depth per cut, means in one cut it will remove only 1 mm, and generate this again. Okay, again verify. Right, now it is cutting properly 1 mm per depth, but here it has left some material on this face. So under this specified cut area floor, I am going to add one more face as a cutting face, but don't select directly, otherwise tool will come directly and it will clash with this face. So click here, add new set, and new set will come. Now select, and here you will find 1 and 2, first face and second face, and OK. Generate again. Let's see verification. 1 mm in each cut. Now wait, we have defined this operation as a roughing operation. Still it is removing the complete material and it is working with the finish operation. So we have missed this. So final floor stock, I want 0.25 mm material on floor, and again for wall you can click here, or you can select 0.25 for wall and generate, and the material will left 0.25 mm on wall or and floor, both area. Let's verify. Right, wait, one more thing. If we are using very first operation, so that time we can use blank geometry. Blank geometry, the stock we have defined as a blank geometry, so it will remove this. Here it will not make any difference, but it is advisable if you are using any prismatic object. For first operation, use this blank geometry. For second, third, or any other operation, you can use this 3D IPW. And see this. Now the first pocket is removed. Now I am going to cut this second open pocket. Click OK and OK. Click here, the same operation, but this time we have one open pocket. The same tool I am going to use. Workpiece is again same. Method is rough. Here select the cut area. So cut area is this one. This is the cutting floor. Automatic wall, it will get the automatic wall. Stock 0.2 I want to left on the floor and 0.2 on wall. Right, see here, now we cannot use this blank geometry. We will select this 3D IPW, the material which is left after the first operation or second operation, that is IPW, and the cut depth of cut is 1 mm for this operation also. Generate. See, the tool path is generating for this pocket and this pocket for both, but we have selected only this face. Still it is cutting the this face. Let's see the verify. Click here. Oops, not properly visible. Click OK. OK, and you can click here so that we can see the IPW. See, this is the IPW, means after this operation this material will left. Okay, and click here for 2D replace. See this. After this, open pocket tool will remove the 0.5 mm material from the first pocket. Please wait. Now see, now it is cutting the 0.5 mm because we have defined 0.25 mm stock for this pocket and 0.2 for this pocket, right? That's why. But we have selected only this single phase. Why it is moving on this phase? It is moving just because of this blank outline. So blank outline is this face. This complete face is a outline face. Blank is still the same as this blue face. So now select this none and it will not detect the complete face. It will remove or it will generate the toolpath for this open pocket only. And again see the toolpath will generate and it will start. Okay, and okay, let me check why it is doing like this. Save this first. If you are facing the same problem, save the part and restart the annex. Right now, double click over it and verify. Come to this and let's see. Now, if you will see, the tool is starting from the center and it is going outward. So, cutting direction is outward. If I want to change the direction, so okay, come to this strategy and here you will get this pattern direction outward. So tool is starting from inside and going outward. If I am selecting inward, so tool will start from the outside and it will come inside. Generate this, verify, say this, okay, and okay, and you can see this in wireframe also. See, now it is starting from outside and coming to inside. See one more thing, if you will see this tool path, you will find corner. See, here we have the corners. If I'm going to select this smoothing option and for smoothing for all passes and the radius is 50% of tool means 4 mm will be the radius of this corner. See here we have smooth corner for all other faces, right? See here. If you want to reduce this, we can also reduce this. And this option for optimization, if you are cutting multiple pocket on the same time, so that time we can decide the sequencing of cutting areas. We will see this in upcoming lecture. So hope you understand this, and in upcoming lecture I will tell you how to add the machine and how to generate the CNC program and post processor also. Thank you for watching. See you in next lecture.